Welcome back to the Nmap port scanning. In this session, we are going to talk about the UDP scan. So, while most popular services on the internet run over the TCP protocol, but UDP services are widely deployed. And as we know that this user datagram protocol is a connectionless protocol. It just sends the packets, whether those packets are reached to the destination or not. That means it won't go for any acknowledgement purpose, so it will get very limited responses also for particular services. And those responses are in terms of your ICMP type 3 code 3 in the header field of your user datagram protocol, that flag header field. And sometimes it may not get any responses also. So let us see. As said, the UDP services are widely deployed on the internet, like your DNS, the SNMP, your dynamic host configuration protocol DHCP. They are the registered ports, like 67 or 68 for your dynamic host configuration protocol, and for DNS it is 53, or for SNMP either 161 or 162 ports. So these are three of the most common UDP services which are widely deployed for these applications. So, because UDP scanning is generally slower and more difficult than TCP, so some security editors ignore these ports, but this is a mistake, as exploitable UDP services are quite common and attackers certainly don't ignore the whole protocol. So fortunately, Nmap can help inventory the UDP ports. So here in this UDP scan, how it works? It works by just sending a UDP packet to every target port, right from port number 1 to your 65,535 ports, or by default it sends to the most common ports. So the most ports, this packet will be empty for most ports because there is no payload in that. But for few of the more common ports, a protocol specified payload will be sent to it, because it is working for the more common or registered ports only. So when the this UDP packet is received by your target, then on target side, on every port, those applications will open this packet and look. These packets are generally the blank packets. If nothing is there, how to respond for those particular packets is not known. So generally targets, they don't generate any acknowledgement packets for that and send it back to the pen testers. So for the open ports, suppose only these ports are open, so all the for the remaining ports, this UDP packet is empty for remaining port, because there is no payload in that particular case, right? So based on the responses or the lack thereof, the port is assigned to one of the four states, like open port or closed port, or open filtered or closed filtered ports. So let us see the example for your open port. So it is the unusual response, because your pen testers may or may not get the response for the UDP packets from them. So this is, as said, for only few or common ports like 53, the payload will be there, so we'll get the response. For remaining, it is empty. The UDP packet is empty, so target may or may not send the acknowledgement for that. So in the uh, closed port case, your pen testers send a UDP packet, and if there is a payload in that, then it receives, the pen tester receives a reply, ICMP reply packet. In that ICMP header, if the port is the message is given as unreachable error and having the code type, that type 3 and code is 3, it informs the nmap that indicates the nmap that the port is closed. The port is closed. Or in other case, if the the pen tester sends a UDP packet, and if those ports are supposed filtered, then pen tester will get a reply or probes a response, like ICMP unreachable error, by having by which consisting the code of this 1, 2, 9, 10, or 13. That is the interesting part here. So the most curious element of the version in this UDP scanning is, if the firewalls or IDS or IPS are installed or configured and target side. So unfortunately, the firewalls or filtering devices are also known to drop the packet without responding. So in that case, the nmap will never get any responses. So then it assumes that on target side, whether the ports are opened or filtered is not known. So this is, in this case, it is a symptom of the biggest challenge with the UDP scanning. Open ports rarely respond to empty probes. Those ports for which nmap has a protocol specific payload are more likely to get a response and be marked open. But for the rest, the target TCP/IP stack simply passes the empty packets up to a listening application, so which usually discards it immediately as invalid. So if ports in all other states would, like in maybe in the closed state or filtered state, or in other states, uh, they would respond it. So then the open ports could all be deduced by elimination. So unfortunately, firewalls and these filtering devices are also known to drop packets without responding. So when nmap receives no response after several attempts, it cannot determine whether the port is open or filtered. So when nmap was released, the filtering devices were rare enough that nmap could simply assume that the port was open. But the internet is better guarded now, so nmap changed in 2004 to report non-responsive UDP ports as open filtered instead, right? So we'll see this on the Kali Linux machine, how it is going to be work, that we'll try to demonstrate. So let me quickly share the screen, the Kali, and we close this one. So here you can give the command for scanning this UDP scan command. Uh, as we said that uh, by just issuing the command here, the nmap, sorry, nmap, and scan the ports which are using your UDP services, and giving their versions also, to find, give the switch that -v, and scan me, sorry, scan me dot nmap dot org, and just entering. It takes much time. Why? Because it is going to do the it is slower compared to a TCP port scanning. So now it is you can see that the increase the send delay for the target that 45.33.32.156 from 0 to 150 due to the max successful try number increase to this one. So here it is going to scan all the ports and it takes much time. So up to now you can see that UDP scan time is about 3.87% done. So remaining percent, it takes much time. Sometimes it takes 20 to 25, 17 minutes time to completely scan this particular process. So let me just quickly about this and give the time limit that let me just wants to scan only the nmap to this. I don't want to go for any the port the host discovery. So minus pn is given. So ping. So there is no need of pinging the host. And I'm going to scan only the given ports like 53.67.161.22. Okay. And by just giving this, it will give you the certain results, but still it takes 1.49 seconds of time. So in that, your port number 22 on your UDP service is closed, whereas your 53 is open and filtered. So that means on destination side or target side, maybe firewalls or intrusion detection and prevention systems were configured so that it is not getting any response. So it is not sure that nmap not sure that whether the ports are opened or they filtered. So that's why it gives the response as open or filtered, whereas the 67 and 161 ports are giving the service for dynamic host configuration protocol and the simplest network management protocol. They are closed. They are closed one. So you can see here, this scan of that demonstrate the open filtered ambiguity issue as well as another problem. That is, UDP scanning can be slow, and scanning 1,000 ports took almost 17 minutes in this case due to the ICMP response rate limited to you're finding the ICMP response rate in this case that is limited performed by these uh, scanme.nmap.org. So, and the most other Linux systems, this it takes the same time. So, Nmap provides ways to work around both problems. So, by just giving, in the case of the scanme.nmap.org scan, all but the three open filtered ports were closed, and the so you can downstream it by just increasing its speed as by just giving let me test for another site, so whether it will work or not. Let me just check the version for your the Felix. So it is giving that is failed to resolve this Felix because there is no targets were specified in that case. So let me just use the time here for scan me, and supposed to increase the time. Here we use the time for scanning these ports on this machine. So that minus T4 switch is used, or the flag is used to speed up the scanning process or for the fast scanning. Even though it takes for all the 1,000 ports, whether they are opened or closed or open closing one, still it takes some times because still it gives up the port because the retransmission cap is still taking time. So this is one drawback of this. So to send the proper packet for every popular UDP service, Nmap would need a large database defining their props format. So when the version scanning is enabled with the switch minus S and capital V, so it will send the UDP props to every open filtered ports. So if any of the props elastic a response from an open filtered port, the state is changed to the open. So that how it is taking time. So how that can be done by giving the specific ports. Let us say minus capital P. No need of doing this scanning minus PN, and for only these ports, or you can give the range of ports like from 55 to suppose the 400 ports. It also still takes much time, so let me get 200 ports, and there to scan the versions of those port services means when the version scanning is enabled with this minus S minus V, it will send the UDP probes to every open filtered ports. So if any of the probes elicit a response from this port, the state is changed to open, and the result of adding minus S of V to the scan will see on the screen now. So it is going to scan the ports from 53, 54, 55 up to 200, and it's still taking time. So let me just reduce these port numbers. Instead of this range, let me use the specific port numbers like 53 and suppose 22, 113, for DNS suppose 67, and for SNTP 161. And let me speed up this by giving the command that minus T of 4 times. And let us see, how many for this for these 5 ports. It is taking much time. So as we said that the UDP scan is much slower than the TCP scan. So this the scan shows that the some of the ports are definitely open. So let us wait for the result. Still, it is taking much time. So let me just close it and just go for only few ports. This is the drawback. It's very slow. For let me go with single port for that. How much time it takes for single port also for sending the scan. It taking much time. that scanning the scanme.org for one port, the initiating the service scan at this time, but still it's going on. So that is the major drawback of this UDP scan. Right? So this UDP scan are very slow. Running even a basic UDP scan on the default 1000 ports can take a significant amount of time. So once again, it is worthwhile to compare the total scan time. Right? So now let us stop this and compare the scanning of single. I don't want to go with all these numbers. And let me just check it out, the port numbers 53.22 dot or 111 113. Okay, just go for scanning for these ports. You will get this. The 22 port number is closed, 53 port number is open, and 113 is closed for authentication. Right. So now let us give the command here that minus scan TCP connection also together. So you can see observation here is 22 port number TCP is open, which provides SSH service, but 22 port number UDP is closed. That means your SSH service runs only on TCP connection, not on UDP connection. So in UDP ports, it is closed and it is not responding, whereas your SSH service is running on 22 port number of TCP connection. So these are few of the observations of the UDP scanning, right? So thank you. We'll discuss the next scan in the next class.